From the Donald Danforth Plant Science Center, HEC-TV, St. Louis Public Radio, and the Danforth Center present Conversations, a discussion about next-generation bioenergy.
I'd like to welcome you all to the Danforth Center this evening. I'm Hal Burrows. I'm chairman of the Conversations Committee, and hopefully proof positive that even liberal arts majors can make a contribution to the Donald Danforth Plant Science Center. Thank you for joining us this evening as we talk about the potential for alternative energy sources, particularly renewable biofuels, to transform major industries including aerospace and aviation, and how it is impacting plant science research and our region. Thanks to our Friends Committee, and to the Conversations Committee for their continued support and commitment to this program. Let me remind you of the mission of the Danforth Center, which is to improve the human condition through plant science, feed the hungry, and improve human health, preserve and renew our environment, and enhance our region as a world center for plant science. And a word of thank you to this evening's sponsors, St. Louis Public Radio and HEC-TV. The HEC-TV recording of tonight's event premieres on May 29th at 5 p.m. and is repeated at various times during the month of June, as I recall. Note that thanks to a supportive community, the Danforth Center can not only host these programs, but carry out its important work. There is terrific attendance this evening on a beautiful May afternoon. How many of you all are here for the first time? Well, that's great. It's always good to see. We're happy to have you here and happy to get you more involved. Excuse me. If you've not yet supported the Danforth Center, please join us. And there'll be a table out front on your way out in the lobby. There's more information about the Danforth Center. Now, I had to promise Dr. Carrington no more Twitter jokes. So during tonight's program, we will incorporate Twitter as a means to collect questions for our distinguished panel from the audience, as well as from others who will follow the conversation remotely. For those of you who tweet, please tweet us your question. Please tweet us your question, @ Danforth Center, and view selected tweets on our tweet wall. The hashtag for the event is, I think that's a number sign, but it's now called a hashtag, ConvoSTL. Whatever. Okay. For those of you who do not tweet, no worry, we will still collect question cards until 6:35 p.m., okay? And transfer your questions to Twitter. Okay, I do subscribe to Twitter, but I don't know how to use it. Anyway, instructions for how this will be accomplished are included on your question card. There are ushers about the room here and there, so please feel free. Ask a lot of questions. It's always good. The use of Twitter is a way to share the discussion and expand awareness of the exciting things happening at the Danforth Center and in our region. At this time, I would like to introduce our moderator, Chip Lerwick, National Business Development Director of Aon Food System, Business and Beverage Group, and our distinguished panelists, John Tracy, who's Chief Technology Officer and Senior Vice President, Engineering, Operations, and Technology with the Boeing Company, Dr. Tony Kuchin, Vice President for Research, Principal Investigator, and member of the Donald Danforth Plant Science Center, and Jerry Steiner, Chief Executive Officer, Arvogenics Corporate Company. And I'm hopeful that they will address how on earth St. Louis is going to catch up with New York in the area of renewable fuels. As Dr. Kuchin mentioned on the radio this afternoon, that pond scum is being used in the context of renewable fuels, and we all know that New York has the Mets. So anyway, thank you.
I did too. You telegraphed that one.
Thank you, Hal. Thank you, Hal. And as Hal mentioned, I'm Chip Lerwick, and I lead business development for Aon's Food System, Agribusiness, and Beverage Group. And in that capacity, in my day job, I work with food and agribusiness companies across the food-ag continuum, working on risk and human capital solutions. My other role that I play here at the Danforth Plant Science Center is I serve on the Danforth Leadership Council. So both professionally and in my volunteer capacity, I'm delighted to have the opportunity to moderate tonight's session because it's of particular interest to me, given that we're talking about bioenergy. And these are sources of fuel that are coming from crops in many cases, or from pond scum, as you may have mentioned. But we've got a lot of interesting things that are happening in this space that really is a wonderful highlight for what we're doing here at the Danforth Plant Science Center. So Hal mentioned the mission, and when we're talking about improving the human condition through plant science, one of the ways we're doing that is by looking at sustainable ways to grow food, fiber, and fuel. So tonight we're going to focus on the fuel aspect of what we're doing here at the Danforth Plant Science Center, and really going to enable that through a good conversation with three guests. And I'm going to expand on the introduction, and then we're going to turn it over to a good conversation. So if I might, first we have John Tracy. He is the Chief Technology Officer at the Boeing Company, the world's largest aerospace company. His 35-year career at Boeing includes serving in dual roles of CTO and Senior Vice President of Engineering, Operations, and Technology from 2006 to 2016. Dr. Tracy's been recognized by many external entities, including being named member of the National Academy of Engineering in 2013. Jerry Steiner, CEO of Aviation, has 34 years of agricultural and life science experience in marketing, sales, strategy, global commercialization, public policy, and acceptance for biotechnology. Argivenics is dedicated to the development of field of pennycress as a winter cover crop that is also oil seed source for renewable diesel and animal feed. And lastly, Tony Kuchan. Dr. Kuchan is the Oliver M. Langenberg Distinguished Investigator and Vice President for Research at the Danforth Center. Dr. Kuchan is currently investigating aspects of natural products that are found in plants which have potential applications for use in medicine and as compounds for biofuels. So tonight, we're going to start this conversation with what is biofuel? What are we talking about when we're talking about biofuel? And I asked Jerry to kind of kick us off, to give us a little context for the conversation. Give us a little sense of what are we talking about?
Well, by the way, first of all, you know how when something just comes to your mind, you want to say it. When you started talking about pond scum, the Mets were exactly the first thing that came to my mind. And I almost said it on the air, but I didn't. I think probably our first, I would guess most people's experience with biofuels in here is wood, on the plains, dung. That was a very important fuel. If we think about it in the modern era, we go back to really the era that's shaped from today. It goes back to maybe 2005 to 2007 when the renewable fuel standard laws first came into place. And the goals behind those laws were really three, and the emphasis on them was different depending on maybe who was looking at it. One of those was energy security. You can remember the time frame looked really very different in 2005, 2007, where a very large percentage of our oil was coming in from foreign sources, especially countries that weren't particularly friendly to the United States. And John, you and I were talking a little bit about the Navy, especially the whole armed forces, really still look at energy security as being a really important piece of biofuels. The second piece was greenhouse gases, and that gets to the core definition of what biofuels are. We're using carbon in the same cycle that we're burning it in. So it's pulling it through rather than anything that would add to carbon dioxide in the environment. And the third was really this was a tremendous opportunity for some economic development. So that all really got started with corn-based ethanol. That paved the way. The standard there was that those fuels needed to have at least a 20% greenhouse gas reduction. But that was really only intended to start it. We really wanted to get it going and then move into advanced biofuels, which is what we're talking about here tonight. Particularly, that's both cellulosic ethanol and other forms of ethanol, but also the whole biodiesel and renewable jet fuel category, which all of these advanced fuels have to have at least a 50% reduction in greenhouse gases. What Arvigenics we're focused on with pennycress, we'd like to see that be 80 or plus percent. It's about making the feedstocks available that's going to make the big difference and doing them both environmentally and cost effectively, and that's what we're working on.
That's great. So we know a little bit about what we're talking about with ethanol, next generation biofuels, but we have to ask the question for Boeing, Why biofuels? What is Boeing interested in relative to biofuels?
Yeah, I would imagine it is surprising for a lot of the audience to see that Boeing is interested in biofuels, and we're very interested in biofuels. Our industry is in a tremendous growth phase right now. In terms of commercial airplanes, over the next 20 years, there's going to be an addition of 34,000 new commercial airplanes. The commercial fleet's going to grow from 20,000 airplanes to over 40,000 airplanes, the kind you would take out of Lambert Field to fly to New York if you wanted to watch the Mets, say, or look at the ponds. And as that fleet grows, the impact on the environment could grow. Today, the commercial fleet is responsible for 2% of the man-made CO2. So 2% of the man-made CO2 in the world comes from commercial airplanes. And that's a very small number compared to other things like cars or heating your house or industry. But it's a number that we feel responsible for. We feel compelled to be good environmental stewards. And so as the number of planes grows, the amount of CO2 they put out could grow to something like 4% of all man-made CO2. That's unacceptable to us. So biofuels are the way that we can see the commercial aviation industry continue to grow. And this industry is like something like 5 to 8% of the world's gross domestic product. So it has to grow for the sake of the economy. It can continue to grow, but it can grow in such a way that the carbon footprint of it actually goes down. As the feedstocks are growing, they're absorbing CO2, and the amount of CO2 that they put out, when we're burning them, that's the same as before, more or less. But we can see a net decrease of between 50 and 80% of the net CO2 used by using biofuels. And so that's why Boeing is so interested in biofuels.
Yeah, a lot of demand coming, and we need to find a way to solve that problem. So we've got advanced biofuels, and thinking about what's on the cusp. When we're looking at research, Tony, what do you see as kind of the next wave of biofuels? Describe them some
biofuels of the future. My answer is going to have many parts to it. The first point that I want to make is that there's going to be no magic bullet. That means there will be many answers to the question of how we produce renewable fuels. If we're looking at the plant, let's bulk plant and algae together because we can view algae as being plants also. There'll be many potential plants that can be used to produce biofuels going forward. I'll just name a few that maybe we'll talk about in more detail. Next to our own heart here at the center is Camelina sativa. This is a plant that is of European origin that is related to canola. Sorghum, plant of African origin. Sugarcane is a possibility, plants like switchgrass. So a number of plant species. The plants will have to be grown sustainably. They'll have to be grown locally at various places around the world. That's why potentially so many different kinds of plants will be involved. They'll have to be processed into fuel locally also. And the economics will have to work out. It'll have to be de-risked when it's up against a market of wildly fluctuating fuel prices. So that means we have to build into the plant systems or the processing some kind of value added that protects the farmer growing these plants for fuel purposes from a fluctuating fuel market. So there's a lot of things that we have to work on from a research point of view to produce the correct number of plants and plant species that can grow in many, many locations, not just around the United States, but around the world.
Are there some attributes that you're looking for when you're identifying the right plants to produce biofuel?
Two different attributes. One, if we're going to press biofuel from seed as an oil seed, then we're looking for plants in any case that require relatively little inputs. And what I mean by that is less water, less fertilizer. Can we potentially grow also in areas that are not used for food production today? If we're looking at plants where we're going to take the biomass, you've heard this lignocellulosics, that's basically the indigestible parts of the plants that give them their stiff structure. Then we're looking for plants, again, that will require little input, not so much water, not so much fertilizer, and grow just like crazy during the growing season to produce as much mass as possible during the growing season. And that can be converted into fuels or any number of chemicals by something like hydrothermal processing, where you apply heat and you apply pressure and you reduce what looks like a plant into a liquid biofuel.
So the attributes, good segue, Jerry, to you. Tell us a little bit about what you're doing with Arvogenics and Pennycrest, because I think you capture some of these attributes.
Yeah, I think Dr. Kuchin said it very well. You know, we're going to need lots of solutions because the numbers are enormous for what we need. John, you were talking on the radio here, you know, 70, 80 billion gallons in aviation, probably 35, 40 billion gallons if you look at the diesel market. So we need lots of stuff. Today, the entire renewable diesel produced is less than 2 billion gallons. So to put that all in perspective. So we're going to need lots of solutions that uniquely fit. What we're aiming to do with Pennycrest, which is also a cousin of canola, it's got a lot of similarities with Camelina, is that we're aiming to fit into this very productive Midwest where we can grow three crops in 2 years. So the way it works for those of you that had a chance to see the display outside is that we would aerial seed over the top of standing corn. That enables our plants to get started even before the corn is harvested. It doesn't have any impact on the corn. You have a nice rosette and cover of that field, so it's a cover crop holding soil and nutrients, scavenging that nitrogen that's left over after the corn crop, so making it a low input crop, and then harvesting in spring. As a matter of fact, we have a field out in Chesterfield. As soon as we can get the little bit of drying up here, it's ready for harvest. And then the day after you're harvesting, you're no-tilling soybeans, a full season soybean crop, into that same field. And this is the right time for planting soybean. So we're not making a trade-off on the corn. We're not making a trade-off on the soybeans. We're able to put that extra crop in between that has some environmental benefits because it's holding on to soil. It's putting a root system down that improves soil structure, but it's also producing a new feedstock that's an excellent feedstock for renewable jet fuel or renewable diesel. And I think it's things like this that fit uniquely into the system that can take advantage of a place where we're not trying to outcompete a food crop or anything else. That's the kind of solutions that I think are going to make a lot of sense for reducing greenhouse gases and making economic sense.
Yeah, it also addresses, I know there's been a lot of discussion around the competition of food versus energy with traditional ethanol, so it's a great idea. When we're thinking about these fuels and how they're being used, John, tell us a little bit about it. Are these advanced fuels currently being used? I mean, we're all familiar with ethanol in our cars, but what are you doing in aviation? And
yeah, Tony and Jerry both talked about sort of future research angles and that sort of thing, but the industry is already taken its first steps. In 2008, we flew our first flight with a commercial airplane using biofuels. In 2011, the international standards body, ASTM International, American Society of Testing Materials International, certified the use of certain biofuels for flights. Since then, we've probably had close to 3,000 flights. Flights that you've probably been on and haven't known about, where biofuels have been used in a mixture with petroleum-based fuels on commercial flights going to New York to watch the Mets or wherever you want to go.
Who does that? Yeah.
While you're looking at your Twitter feed, I guess. I learned a lot about Twitter today. And so this is not something far out in the future. This is a reality today that's impacting your lives today. The progress we need is we need to have these fuels be affordable, more affordable. We need to have a robust supply that's all over the world. If you look, 50% of the fuel for aviation used around the world goes through 20 airports. 80% of the fuel goes through just 80 airports. So and we don't need a new infrastructure. We use the current infrastructure, the current engines on the plane, the current fueling system, the current fuel tanks, the current fuel delivery systems, All of that, we can use these fuels with that infrastructure just as they are. So this is a near-term possibility. It's just a matter of economics and scaling it up.
So I think we need two things, really. You know, we and this is where the Danforth Center is extremely important for us. We have to develop these highly productive feedstocks that are going to be worth a farmer planting. So even though we're fitting in between two crops, the farmer's still relying on that. We're going to get that crop mature and ready in time for when they want to plant soybeans. And you still got to run a combine across the field. So it's got to be worth it. So we've got to do our work in making the productivity come up. And the work that we're doing here at the Danforth Center, this is just a fabulous place for a new company like ourselves to be able to be doing that groundbreaking work. There have been very few new crops domesticated in a long time. So this is not easy work that we're trying to do. The second piece that we need, and this is what Tony talked about in terms of taking the volatility out, you've probably heard many companies talk about it, but we really need to put a clear price on carbon. If we want people to really invest and invent solutions that help us address taking more carbon dioxide out of the environment, we need to make it more transparent. That's where policy is also important.
Yeah, that's important. So there are some enabling factors that probably would help ramp and scale this. And Tony, we talked on the phone the other day about there may be some political movements that are driving some of this, either carbon taxes or what have you. Can you share with us just some of what you're hearing?
What we spoke about is an initiative now in Washington State. I think Washington State is the first state now to introduce the possibility of a referendum on introducing a carbon tax that will come up to vote in November. I think that's one way to do it. You can make current fuels more expensive that way. Another possibility is to engineer added value into the bioenergy crops too, to make them worth more to a farmer. And what I mean by that, you have two possibilities. Again, it's to battle the economics from fluctuating fuel prices. You can produce in a plant, let's use sorghum as an example, some very valuable commodity chemical that's first removed from the sorghum, and then the sorghum biomass is converted into fuel. So the farmer first sells a very valuable chemical and then can afford a lower fuel price when he's processing his sorghum into a fuel. So that's one possibility. And I think since Jerry was talking about what we're doing with plants to make them more sustainable, more valuable, what we also look at the Danforth Center is two different aspects. One is improving quality of oils by engineering the oils, for example, for higher energy density, so it becomes more reasonable as a jet fuel, making it more valuable that way. And on the other end is improving the sustainability of production. So let's talk about sorghum, making it even more drought tolerant than it already is, or making sorghum, finding sorghum varieties through breeding or just natural selection that require fewer inputs, fewer fertilizers. So when you look at the whole assessment of growing the plant and producing it into a biofuel and selling the fuel, it costs less because you need less water, you need less fertilizer to grow the plant, and then you're playing with the economics, the challenging economics that way also.
We believe in the work of the Danforth Center because it gives us options. Boeing will never be in the biofuel business, but we know for our industry to thrive, there have to be biofuel options. So we never intend to pick winners and losers. We just want there to be a broad range of possibilities. And one of the things Tony said that's critically important to us is the word sustainable. We have got to make sure that we don't impact food security for people, or water, or land through our promoting of aviation. With respect to the tax things, I agree that the tax on carbon is an incentive, but our industry, the commercial aviation, we've made a commitment as an industry that every year we will make sure that the fleet is 1.5% less CO2 producing and less fuel using than the year before. We've made a commitment that by 2020 we'll reach what's called carbon neutral growth, where even though the number of airplanes is dramatically going up, the amount of CO2 we put in the air as an industry will be the same as it was in 2005. And our last commitment is by 2050, we're committed to seeing the amount of CO2 that's put into the atmosphere from commercial airplanes be half of what it was in 2005, even though the number of airplanes is double or even triple what it was in 2005. And these are just commitments we're making because we know our customers demand that, independent of any sort of regulatory or economic structures that are put in place to encourage us.
John, you're putting planes into fleets all over the world.
Yes.
And we've talked about the fact that there are going to be different solutions for different places. What are you seeing outside of the United States in terms of development in this area, in terms of next generation?
We have partnerships and relationships where we act as the catalyst in every continent with the exception of Antarctica. Okay. Every single one. And in each location, they're quite different, quite inventive, quite novel. The plant materials have to be developed for that local region. They have to be developed in a way that they fit into the local economy and help develop the local economy as well. So for us, it's about having a broad, robust range of options. But people all over the world, in every country we fly, are very interested in biofuels and the impact they can have on the environment.
When I think about that local economy, I think about our local economy, and we've got a tremendous amount of agriculture that's happening in this area with soybeans and corn. And Jerry, you've talked about double cropping, essentially. What impact do you think regionally a pennycress crop might have on those farmers and rural communities, and how does it benefit them, even beyond the economics?
Yeah, I think it benefits in a couple of ways. I mean, first of all, whenever you're bringing a new crop in that ultimately will be linked to a little different marketplace, you're going to bring some diversity, and I think bringing diversity into the economic equation is always a good thing over the long term. In addition to the financial side of this right here for the farmer, we're seeing there's a growing movement of cover crops in the United States. We're probably at about 5% of the land across the Midwest where a farmer is now putting a cover crop in. And if you think about it, I mean, these last couple of years have been pretty tough with farmers, and it's grown during that time frame. They're investing $20 to $30 an acre to put in a cover crop, and they're doing it because they believe in the advantages that they're seeing for their long-term soil health. Some of that is holding onto the soil, especially you remember that massive rain event that we had here in St. Louis last December. Some of it is holding on to nutrients better. A lot of it is building soil structure with more macropores, which leads to improved drainage and nutrient availability as well as a healthy micro population. What we think we can do with a crop like this is we can deliver those kind of cover crop benefits, but instead of it costing $20 to $30 an acre, the farmer is going to make a profit. And that leads us to believe that instead of this being on 5%, we can be on a very large percentage. And that's going to improve soil health. That will improve productivity. That to me fits the whole definition of what sustainability in agriculture is really all about.
Yeah, it's hard to put a value on some of those other factors in terms of improving soil health. That may have a material impact.
But farmers clearly, some leading farmers clearly believe it because they're already spending the money. But it's still only 5%. It needs to be 100%.
Right, right. Tony, you've alluded to some of the various crops and plants that are being considered, and you mentioned Camelina here at the center. Can you tell us a little bit more what specifically is going on here in the work?
So a little background on Camelina that I mentioned briefly. Camelina sativa looks a lot like canola. It's of European origin, but it was never developed as a crop plant in Europe. It is a plant that is very, very similar to a plant that we use as a model system, just an experimental system in the laboratory, so it's very easy to work with. It produces an oil seed. It is, since it is not used for foodstuff production, it is an interesting plant to use as a chemical factory where we can engineer, using genetic engineering, the capacity to have specialty oils in the seed, to increase the content of oil in the seed. As I mentioned, we can engineer the ability to make chemicals that occur in other plants in its seed that increase the energy density to make it more suitable as a biofuel. And it's a plant that the Danforth Center has been developing for the past 8 to 10 years with very generous funding from the Department of Energy as a chemical factory, as a biofuel, biodiesel producing plant that has potential to intercrop or double crop also in this region in the Midwest. But other areas around the country also. The Northern Plains is a suitable area, as is potentially the state of Washington. So we look, again, always at economics in these kinds of projects. What we know is that we can make very, very good biodiesels. And I think John would agree that the plant diesel fuel that's made is in many characteristics superior to petroleum. So the challenge is not can we produce the good quality, but can we produce enough of it around the country, and can we produce it in an economically competitive way?
With respect to Tony's question about enough of it, we believe the tipping point is 1%. Once we get to 1% of the fuel supply, which is 70 or 80 billion gallons a year, once we can produce 1% of that, we think the industry takes off. And what we'd like to see is 30% of the aviation fuel available by 2030 at comparable economics. And from what we're seeing, we think that's absolutely possible.
Just to touch on that quality for a moment, it was interesting on the call today, there was a gentleman who called in with a question. He seemed to be well informed around the engineering and requirements for aircraft.
You were doing a lot of math very fast. Yeah.
He was a smart guy.
But there are some tremendous benefits that these fuels are demonstrating.
When we have to specify, we have to pass a series of tests on these fuels. And two of the easiest things is the amount of energy per kilogram is higher with biofuels than it is with petroleum fuels. The freezing point is lower, which that's a good thing because you don't want the fuel freezing when you're on the ramp.
Even if you're going to a Mets game. Yeah.
Even if you're going to a Mets game. It doesn't have sulfur or soot in the output, so there are other things that are good for the air about burning biofuels. So it's just a winner all ways around.
That's great. So we've got our first tweet. This is it, breaking news. So Tony, you may have addressed some of this in your description, but what are the greatest technical challenges and what are legislative hurdles for widespread use of the new biofuels?
The real challenges, I think, lie in the economics. As I said, the science is there. We know how to make better plants either through breeding, looking at diversity out in nature and improving our biofuel crop plant or genetic engineering. The real challenge comes with the fluctuating prices in the fuel market. So what looked great yesterday, today, suddenly is too expensive as a biofuel. So how do we mitigate that risk so that it is economically viable for farmers to convert land over to large parts of cover crops, or for new farmland to develop in the non-arable parts of the country and grow a plant that they know that they can convert into a biofuel and sell to somebody at a reasonable price.
So I'll just add to that, I think the other challenge, especially as a private company, is just the time factor. We get our report card out of the field about this time of year. We haven't quite got it this year yet. We'll get it in a week or two. And you really get one test per year where you really know how you did out in that field. And you have to make these genetic advancements, but you only really get that one test per year. We are very fortunate by having the systems that we have here at Danforth that we can get multiple cycles, and we've done a lot of things to try to speed up the cycle so we can speed up genetic advancement right here. But in order to make the economics work, we have to make these plants be productive. That's what every crop that has been domesticated from someone wild is that plant breeders over the course of time have made them very, very productive. They've made them more reliable. They've made them more durable. And what they've done, and Dr. Carrington talked about this a little bit earlier today, they've really taken these things from nature because plants have figured out how to do some of these things. What we want is that one plant and one variety out there to do all of these things. And that just takes us time to do it. So it is a race against time for us, and I appreciate what John is saying in terms of when he wants these feedstocks ready. So fighting against time is our biggest challenge.
Let me weigh in on that also, because the Danforth Center, many of you know who have been here before, also is very interested in accelerating breeding, and we do this through what we call phenotyping or robotic screening of plants. Many of you have probably seen the phenotyping facility that's down in the greenhouse area here. That's all about let's breed faster. Let's find that special plant with the characteristics that we need as fast as we possibly can, and we do that in an automated way that runs 365 days a year, practically speaking, 24 hours a day. And a newer project that was just funded by the Department of Energy for field phenotyping in Maricopa, Arizona, with the same goal. In that particular instance, it's for sorghum and looking for sorghum varieties that require less water. That's about a 1-acre site, and it's an automated system that when it's up and running fully, will be constantly looking at very, very large numbers of different, up to 400 different varieties of sorghum, again, for those special characteristics that we need for a biofuel crop. So that's the way we're trying to address the speed factor and get to the answer more quickly than we would if we were just using older methodologies.
Genetics clearly is going to be important to overcome some of those obstacles, but the next question is really, we've touched on it from the standpoint of those fluctuating energy markets. But Jerry, this question goes to you, is how's the current disruption in global oil markets affecting your decisions with development with Pennycrest and
Right.
Arvogenics?
Well, we're an R&D company, so it doesn't affect us on the P&L yet because we're not selling anything yet. But it's not just oil. We have to think also about the feed component of what you produce, because whenever you produce an oil seed and you crush it to get the oil out, you also get animal feed, and you have to be able to get value from all components of what you grow in order to make these things economically viable. So those commodity prices do factor into the overall economics. So what it says to us is that it makes us sharpen our pencil a little bit sharper, and pushes us on how we can be more efficient, how we can be smarter about making our development, because it just pushes. We need to get that yield in order to make it work at a full range of commodity prices. And this is why I come back to carbon, because if you add the value of carbon in, you do mitigate the commodity price, because the carbon price would be a stable component of all of this. I'm not up here trying to sell a carbon tax. I think there are a variety of ways to effectively do this, but if that's a piece of the value for it, we need to make it more transparent and permanent. The way effectively it is being done today, and it is helping this whole industry, is by having mandates in the system on the road transportation fuel. It has created a clear marketplace for these fuels to really get them developed. That's been extremely important. It's what holds it together today for us, despite these lower prices. But the implementation of those, especially in the case of biodiesel, has been retroactive. That's not very productive. Retroactive credits are not very productive for an industry you want people to put proactive investment in.
So this next question kind of gets even finer to the point around that differential between the costs of biofuel compared to petroleum. John, is there any sense that you have from Boeing looking at what you're doing and seeing in the markets today?
Yeah, this is a question where rather than give an absolute dollars per gallon answer, I'm going to do it relatively, because it depends how much you buy and what the fees are. But in general, we've seen prices that can be up as much as 3 times higher than regular kerosene. But we see some fuels today that are right on the verge of being certified. We've flown them, but we haven't had them certified yet. Like green diesel, for instance, it's completely comparable to normal diesel, which is slightly higher than jet fuel. So we are certain that if the research continues, that ways and methods will be developed to make this cost competitive with the current petroleum prices.
Right.
I mean, this green diesel, we can achieve the 1% of the fuel supply I was talking about within the next 6 months if our certification process we're working completes.
Wow, that's
so
great.
we're very encouraged by the slope we're on the pricing.
And these demand signals that I think the airline industry has been very strong in sending are really important to the development of this industry.
One of the things we worry about is we don't want all these great biofuels going to trucks you know, and cars. We want to save them for the airplanes and let the trucks and the cars deal with CO2 production with other means like electrification. We can't electrify the large airplanes today. There's just not enough energy density.
Right.
We can use the biofuels, so we're a little selfish on that front.
Some logic
That's a
to
good
that.
point.
Yeah, so in terms of biofuels, it came up a couple times about other sources, and algae is the question that's up right now. It's what's the commercial future of algae relative to other biocrops? And Tony, maybe you could speak a little bit to the differences between algae and other.
I think the future is still out there. A lot of what I gauge as doable is based on interest of federal funding agencies. And the Department of Energy and the Air Force are still interested in funding algal biofuels research. And again, it's part of an answer. There'll be many, many solutions, and it'll be based on where around the world it can be grown and what the local interest is and how good it is for the local economy. But there are still a number of very well-funded projects out there to make algal biofuel production economically competitive. So yeah, I think it has a future, very much so.
We're seeing great interest in algae in China. That's where we've got joint research programs with the Chinese Academy of Sciences to develop algae sources for biofuels. So that's where the interest is greatest for us.
John, you talked a bit about lots of countries are doing work, and you're collaborating with many of those.
Yes.
But this question is really is how do we compare relative to those other countries in terms of achieving a dominant position in next generation biofuels?
Well, I can say with certainty there is no place like the Danforth Plant Science Center any place else in the world. So from that perspective, you've clearly got the lead. The Midwest area in general, we probably have 40 relationships in the Midwest working on biofuels with our Midwest Association of Sustainable Biofuels. I might have one of the letters wrong on the acronym there. But this area is really key to the future of biofuels. I think Honeywell, UOP, key player in developing processes.
CAFE has played an important role.
This really is the heart of the action as far as I'm concerned.
And the funding for a lot of this work that's happening, I mean, Tony, you mentioned the Department of Energy is kind of a primary source of funding relative to much of the research we might be doing here. Are there other funding sources? I mean, perhaps, Jerry, you could speak to just the investment community and their interest in this as well.
Yes, as a company here, we've gotten great help out of Danforth, but we also have been very benefited by the fact that Cultivation Capital, which is here tonight, the Yield Lab, the Biogenerator, State of Missouri, the Helix Fund. So as a city, as a city and a state in this part of the region, making a very good effort in helping companies like ourselves try to make a difference in these kind of challenges. So I think the United States has a very good chance of really being the leader in this. We have just a well-educated population. We can find great talent in this town. So I think, and we're very blessed to have people that are willing to fund our work.
That's good. So we got a technical question for you, John, and that's really about, you mentioned biofuels are blended for jet fuel, but this is a question specifically about what percentage of biofuel is in this blend.
Yeah, the maximum percentage we're using right now is 50%. Some airlines use down to 15%. And the fuels are drop-in fuels, which means you can pour them directly into the fuel tank. The reason that we blend them is there are some compounds in petroleum fuel, aromatics, that help with the seals and that sort of the flow of the fuel. And right now we don't have those compounds produced in the biofuels that are synthetic paraffin, basically. We're working with some of our partners to be able to produce those compounds from biofuel feedstocks, and then we could go to 100%. So right now, 50-50.
Let me add in, because we've addressed this in one of our Camelina projects. So jet fuel is about 18% of the aromatics, And so we were engineering into Camelina seed oil,
Oh, very good.
plant-based compounds that are not quite aromatic yet, but they're cyclic hydrocarbons.
Thank you very much. Good job.
We've got it. And we're up to about 8% of the oil as these compounds.
Very nice.
So we're trying, yeah.
Very nice.
So the next question is, it's a big question. It's the one that we've touched on in a number of ways, and it's really what will it take to compete economically with petroleum? We've talked a bit about scale, but any further elaboration on that, Jerry or Tony or John?
Yield, scale, value in carbon, I think those are all really important elements. And I think time, we're going to have to work at this for a while. I think whether I think of it as a new crop being developed or developing a new industry, it takes just committed effort by a bunch of people. So, my history and most of my career was at Monsanto, as I know a number of folks are here. And if you think of what Monsanto built over a long period of time, they built it because they stayed after it for a long period of time. And I think that's the same thing for our company or for this industry. We really have to stay committed to it because you make breakthroughs, but mostly you make progress that builds on year on year. When you look back 10 or 15 years later, you've done something amazing. That's what I think can happen here.
From our point of view, in addition to that, it's also engineering in the capacity to make high-value chemicals in the biofuel plants so that you can extract out those valuable commodity chemicals and sell them and then use the rest to produce biofuels. And that'll help a lot with the economics if we would be successful with that.
Mm-hmm, mm-hmm. This next question, are the current political barriers to GMOs surmountable? It seems to me that it's kind of a requirement that we use GMO in the production of some of this science that goes in, but Tony, perhaps you could speak to this.
Is it surmountable? Well, in some cases, one can use traditional breeding. In some cases, what I was talking about, adding these high-value chemicals, this will have to come with genetic engineering. Is it surmountable? Sure. A good percentage of the production of the food in the United States is with genetically modified plants. So I think there's public acceptance, and I think if we work together with the public and explain what we're doing, that we can ultimately achieve acceptance. We're not talking about foodstuff plants, we're talking about plants that will produce industrial chemicals and fuels. So maybe it would be a different kind of conversation and a different consideration. But yes, it's possible, and in some cases it will be necessary to use genetic engineering or newer technologies of genome editing, which are a hot topic of discussion right now.
Mm-hmm. Yeah, I know we're doing a lot of work here with that, and it is exciting. I want to come back to a point you made a couple times, Jerry, about the greenhouse gas reduction that we're seeing, and there's a lot of variability. What's driving the variability in some of those numbers that we're hearing in terms of percentage?
Well, ultimately, to give you an example, that California, this is in cars and trucks, so I know it's not in the right place, but California CARB will actually calculate the number for you. So it's, so some of it is the person performing the life cycle analysis is going to end up with their number. So some of the variation comes by what methods and what kind of things that they count. We have had an LCA done on pennycress, and depending on a number of assumptions, because the crop is really just in development yet, it's in the 60 to 85% range. So things like the more productive the feed coming out of it is, the more it doesn't require another acre of corn or soybeans to be grown somewhere else in the world. That helps the LCA. The higher the yield that we get out of the field, that drives the number up. So all those factors move it around. But we've looked at it very deeply, and we very strongly believe we can be above 80%, which will be a very good fuel to be above an 80% greenhouse gas reduction.
Yeah, I would say so. So we're going to get close to the end here in a moment, but I want to give an opportunity for John and Jerry and Tony to maybe offer a closing thought for us as we kind of draw to the end.
Very good. We believe that people like to fly. They like. And we believe that people that like to fly want to be good stewards of the environment, and they want to fly affordably. And biofuels offer us a way to continue to see the growth of aviation in a way that makes us all good stewards of the environment and allows us to fly in ways that are affordable.
I think that what we're talking about are some of the biggest challenges that we face. You know, how do we have a sustainable food security for everyone, having it be affordable, and also have the energy and the environment for the lifestyles that 9-10 billion people are going to want. And that, to me, is going to require solutions that do more than one thing at a time. And I think if we really stay after it, we're going to find these biofuel solutions can be environmentally sound, actually improve what we're doing, deliver economic development and great jobs. I think the and between those two is what's really important. And we have to be working on those kind of ideas, but they won't come overnight. We've got to stay determined.
Final word? Okay, we believe, then in follow-up to the two statements, that here at the Danforth Center, we have the capacity, both the intellectual and the technological capacity, to come up with very, very viable solutions to these global challenges in food and energy production. And if we continue to work together with our end users in industry and work together with our wonderful supporters, we believe that it's not too many years down the line where we'll be coming up with the first of those solutions that can come to commercial realization.
Well, from kind of the research and the supply and the demand, I think we've had a great conversation tonight to really cover next generation biofuels. And now, this is the moment we've all been waiting for. Dr. Jim Carrington.
Go wild with applause.
Thank you so much, Chip. Seriously, that was an absolutely terrific panel. You know, we get asked a lot here. I know Tony gets asked, I get asked, those of us who are engaged in one project or another that relate to biofuels, what are you guys doing with biofuels when the price of oil and natural gas are so low? On the one hand, it's a tough question to answer if all you care about is economics. But I hope that you all received an armament of answers to that question, if you ever get it, on why we need to focus on this problem. The research that we're doing today, not just at the Danforth Center, not just in Avigenics or Boeing, isn't to solve a problem that we have with the price of oil. It's to solve some of the big global challenges we face as we move through the 21st century. The ability that we have to sustain our lifestyles, our interest and needs to fly, these are going to depend on solutions that come out of research and development programs like those here and in the organizations represented on this stage tonight. With that, I want to thank Chip for serving as a terrific moderator and our three guests, although two of them aren't really guests. Tony Kuchon, our Vice President for Research, thank you for all the great work that you do here. Jerry, as I said earlier today, you're one of the models that I point to as the type of innovator, the type of entrepreneur, and the type of leader that we are needing and are growing and are developing here in St. Louis to take us from here to there. Companies like Avigenics, which were nothing just a few years ago, are now something, and they're making a contribution. And we're proud to be a very small part of that, but really proud to have Jerry in the ecosystem here. And John, John, thank you so much for coming down and spending the day with us. You are correct. We're all fascinated with flying in airplanes. Airplanes are heavier than pianos, and pianos don't fly. So airplanes are just fascinating. You don't know how many hours John McDonnell and I have spent in meetings when we should have been discussing business, talking about airlines and the airplane industry. It's a real honor to host you here. Thank you for bringing your insights and your knowledge and the way you see the future, which we're very excited to hear. Thank you all for coming. There are 2 more conversations. Hal, I'm going to give a commercial, a pitch for the next 2. 2 more in 2016. The next will focus on the state and how the Danforth Center is working with the University of Missouri to build plant science and innovation in this region. We're going to have the Chancellor and our own Blake Myers as guests on the stage. And in November, we have Pulitzer Prize-winning writer, science writer, one of the great science writers of our time, by the way, Amy Harmon from the New York Times is going to be here. We're looking forward to that. That's going to be a fascinating evening. Thank you so much for coming. If any of you want to stay around a few more minutes, please do so. If anyone wants to see the new wing and you haven't wandered through it, feel free to take the hallway down and see what we just opened in the William H. Danforth wing. Thank you all for coming.